Good afternoon, everyone. Okay, so I'm going to try this again. Sorry that the first recording did not have sound. Hopefully this one will. Okay, so proportions. Definition: a proportion is an equation. So we know an equation has to have an equal sign in the middle. An equation stating that two ratios are equal. Two quantities that form a proportion are proportional. So that's what we're going to talk about today. How do we know if two ratios are proportional? So this first proportion is read 2 is to 3. 2 is to 3 as 4 is to 6, like an analogy. All right, I'm going to teach you 3 ways to determine whether or not two ratios are proportional. So directions, 3 ways to tell if two ratios are proportional. All right, first one we're going to look at is 8 to 10 proportional to 20 to 25. First method, reduce both fractions or both ratios. I'm going to cross out the word fractions and replace that with the word ratios. Reduce both ratios to lowest terms. So if I divide 8 by 2, I get 4, and 10 divided by 2 is 5. If I divide 20 by 5, I get 4, and 25 divided by 5 is 5. So notice how 8 to 10 reduces to 4 to 5. And 20 to 25 also reduces to 4 to 5. So that answer would be yes, they do form a proportion. So when you start your practice page in Big Ideas, I have to see your math for how you determined your yes or your no. Reducing to lowest terms could be one of those methods. Okay, we're going to reduce to lowest terms again. So divide by 2. And divide by 2, divide by 5, and divide by 5. So 7 to 10 is not equal to 1 to 2. So your final answer will be yes or no. Method 2. If you don't want to reduce to lowest terms, your second method is called using a common multiplier. So if we focus on the numerators of 5 and 15, I can multiply 5 times 3 to get 15. Now, is 6 times 3 18? Yes. So if you can use a common multiplier, your answer would be yes. What about over here? So let's focus on 4 and 8. How do we get from 4 to 8? We do times 2. Is 10 times 2 15? No. Not proportional. Now, I'm going to highlight this in pink. Use caution, because the common multiplier can be a decimal and you would not recognize it. Sometimes your proportions are going to look a little weird, like 12 to 18 equals 14 to 21. Well, if you focus on these numerators, there's no whole number that you can multiply 12 times to get 14. But what if you worked backwards? What if you divided 14 by 12? So you are allowed to use your calculator. So I'm on my calculator right now, and I'm doing 14 divided by 12, and that equals 1.16 repeating. So if I multiply times 1.6 repeating, I get 14. Now, what is 18 times 1.6 repeating? 18 times 1.6, that's 28. So that would be no. Now, you can also do reducing to lowest terms. Remember the other method that I taught you, which might be easier on this one. So if I divide 12 by 6 and 18 by 6, I get 2 to 3. 14 divided by 7 is 2, and 21 divided by 7 is 3. So I must have made a silly error with that previous one. So this first answer would be yes, because I have 2 to 3 for both of my ratios reduced to lowest terms. So that one we would say yes. All right, what about 8 to 20 and 20 to 25? If you're using the common multiplier and you can't think of a number that you can multiply 8 times to get 20, you can work backwards. And you can do 20 divided by 8. So on my calculator, 20 divided by 8 says times 2.5. 8 times 2.5 is 20, and 10 times 2.5 is 25. So remember, I said use caution because sometimes that number that you're going to multiply by will actually be a decimal. Now, to check yourself, you can also reduce to lowest terms. So divide 8 by 2, you get 4. Divide 10 by 2, and you get 5. Divide 20 by 5, you get 4. Divide 25 by 5, and you get 5. So 8 to 10 reduces to 4 to 5. And 20 to 25 also reduces to 4 to 5. So that answer would be yes. All right. Cross multiplication is the third method. So you can either reduce both ratios to lowest terms, or you can find a common multiplier, or you can cross multiply. So is 4 to 5 equal to 5 to 7? Cross multiplication is when you multiply your factors diagonally. 5 times 5 is 25, and 7 times 4 is 28. If these are two different answers, you're going to say no. Cross products. 3 times 3 is 9. 5 times 2 is 10. 10 is not equal to 9. So that answer is going to be a no. Moving on to the next page. Now, tell whether the ratios form a proportion. So you can use any method that you want. I'm going to go ahead and start off using reducing to lowest terms. Divide by 2. Divide by 2. That reduces to 2 to 3. Divide by 6. Divide by 6. That reduces to 3 to 4. So if this ratio reduces to 2 to 3, and this ratio reduces to 3 to 4, your answer would be no. Now, I also could have done cross products, or I could have found a common multiplier. Okay, so sometimes when I first look at these, my eyes are going directly to the 6 and the 24 on the bottom. And I know that 6 times 4 is 24, but is 4 times 4 18? No. So that's a real quick one that I can determine that a common multiplier is not going to work. Is 25 to 20 equivalent to 15 to 12? So this one I can see that 25 and 20 have a common factor of 5, and 15 and 12 have a common factor of 3. So these would be real quick to reduce to lowest terms. Divide by 5. Divide by 5. I get 5 to 4. Divide by 3. Divide by 3. Oh, I also get 5 to 4. If both ratios reduce to the same ratio in lowest terms, your answer is going to be a yes. All right, so we can either reduce, find a common multiplier, or use cross products. This looks like one that would be real simple to use a common multiplier. So I know that 6 times 2 is 12. Is 4 times 2 8? Yes. On your practice page in Big Ideas, when you submit that, you have to show me that you've either found a common multiplier, reduced both to lowest terms, or done cross products. So if you want to do cross products on this one, let me find a different color ink. So cross products would look like 4 times 12 is 48, and 8 times 6 is 48. So that could have been your work. You simply could have shown me the product of both of those is 48, and then your answer would be yes. Okay, so this one, I don't think I want to use the common multiplier because I know 18 times nothing is 33. But I do see very quickly that they both have common factors. So I'm going to divide 18 by 9 and 27 by 9, and I get 2 to 3. I'm going to divide by 11 and divide by 11, and I get 3 to 4. So since 2 to 3 is not equal to 3 to 4, my answer for this one is going to be a no. 2 to 4 and 11 to 20. Okay, so I'm focusing right now on the bottom. That's where my eyes went, because I know that 4 times 5 is 20. Is 2 times 5 11? No. This also would have been a quick one to do cross products. So you also could have shown me 4 times 11 is 44, and 20 times 2 is 40. Because 40 is not equal to 44, your answer would be no. You do not have to show me all 3 methods. You have to pick one and show me your thinking. How do you know that these are not proportional without doing the math? Now, since these are ratios, you are allowed to have a number on the top bigger than the number on the bottom. This, for example, could be in our class, we have 10 boys to 3 girls. And in period 2, I have 5 boys to 6 girls. So these are not fractions. These are not improper fractions. These are ratios comparing 2 different quantities. But what I do notice is that 10 is greater than 3. So this answer over here would be greater than 1 whole. But 5 to 6, that would be less than 1. So anytime that you have a ratio with a numerator greater and another ratio with the numerator lesser, that's going to be an automatic no. What about this? Are x and y proportional? Okay, so here's my x, here's my y. The thing you want to focus on here, guys, is the very first ratio given in the table. This is called a ratio table. Now, if I reduce these to lowest terms, if I look at 3 to 8, well, 3 to 8 is already reduced to lowest terms. Is 2 to 7 equal to 3 to 8? No. 4 to 9, can I reduce that one any further? No. Is 2 to 7 equivalent to 4 to 9? No. If I reduce 5 to 10, I get 1 to 2. Is 2 to 7 equivalent to 1 to 2? No. The ratios in this table are not proportional. When you're looking at a ratio table, you always want to focus on the very first ratio given, 2 to 3. And you want to keep comparing every other ratio back to that first one. So if I reduce 4 to 6, divide by 2, and divide by 2, oh yay, I get 2 to 3. If I focus on 6 to 9, divide by 3, divide by 3, I get 2 to 3 again. Because every ratio in this table reduces to 2 to 3, yes, the ratios in this table are proportional. Okay, we are almost finished. The very last skill is finding a missing term. So, quickest way to do this one, so we're trying to solve for x up here. I can quickly see that 6 times 3 is 18. So if I multiply 5 times 3, I get 15. So all you would write for me there is x equals 15. We are solving for x. And again, I quickly see that 4 times 8 is 32. So what is 5 times 8? X equals 40. Now this one, be careful because you're thinking backwards on this one. So I know that 3 times 8 is 24. So what number times 8 equals 16? 2 times 8 equals 16. So x equals 2. Again, you've got to think backwards on this one. Up here, 5 times 3 equals 15. What number times 3 equals 21? X equals 7. Now, let's hope my sound is working. I hope this is working. If it's not, let me know. Thanks, guys. See you tomorrow. Bye-bye.